For myself, what got me into what I'm going to share with you today was really very impractical building. So I'm going to start with a video that kind of represents the sort of stuff that are my favorite things to build. And this, what you're about to see here is it's a flamethrower made from a leaf blower, some 3D printed parts, and a blowtorch. Everything came from hardware sales, pretty much. And it's burning coffee creamer. So right now, like you could look cornstarch into this thing, or sawdust, or what have you. So it's no stretch to say that this is what got me into all sorts of other stuff. Was chasing down these sorts of wild ideas, and there it's like that. So let me mess with my technology for a minute here. Okay, and I wonder if this is going to give me a preview of what's next on my computer. Oh, should I? All right. Forgive me for just a moment more while I embarrassingly figure out this on the fly. That's not what I want, okay? Now let's hear its place. Oh, cool. Okay, that looks like I broke it. That's a good start. Okay. I broke it. I'm breaking things. Oh, okay. Yes. Now if I press play. There we go. Okay. So I'm going to kind of walk through how this design, and this is an out-of-date picture. I need to update this. So let's just put this over this for now. So this is where things are at, or pretty close to where they're at currently. I'm going to share the story of how did a partial hand prosthesis went from this state as far as its initial prototype to where it is today, and basically how spaces like this one or similar to this all over the country and now all over the world have played a pivotal role in making that possible. It starts back with me in high school, building crazy things. This is me and my best friend. He and I still live here in Bellingham. That's us when we were building medieval armor and whacking each other with pieces of wood because we were irresponsible and foolish. I specified to the young people, irresponsible and foolish. Don't do this because it's not very safe. So that's what we were up to back then. Yeah. This is us present day. Not a lot's changed. And of course, when it snows, we had to build a giant snow troll and do all sorts of fun things with it. I think we had more fun with that thing than the kids did that were with us, but obviously didn't want to be in a picture with a couple of weirdos. So at one point, when I was creating various special effects props and things, I was contacted by somebody that wanted to commission me to make something that didn't work. It ended up being a failed design. They asked me to make a mandible mask for them. I ended up cannibalizing it for parts, but this is part of that original armature, which was going to go somewhere here on a big rig and have a motor attached to it and these levers so that when something would turn, it would move and make sort of like a Dr. Zoidberg effect. But when I was building this, and I emailed the guy back and just said, hey, I don't have the tools to do this right now. My tool set was pretty limited when I approached this project. I realized that what I had here looked a lot like a finger. And so I thought it would be fun to build a giant prop hand that was mechanical and very Edward Scissors-like. And so that's what I ended up building was this hand that you see in the photograph here. I decided to put it onto YouTube. Just myself wiggling the fingers in front of a curtain. Yeah, it's appropriate. YouTube's an appropriate place for that sort of weird stuff. But what happened after that was very surprising to me was I got an email. And the email was just very short, as you can see, and it had a picture attached to it, which was a man's hand with some fingers. So the email was from a carpenter over in South Africa by the name of Rich. He had amputated some fingers in a table saw accident. And he was trying to build his own device because he had no insurance being self-employed and in South Africa where, it was the price to get the finger replacements that were on the market where we are was expensive. For them to import them, pay tax, all those things. He was looking at about the equivalent of $4,000 or $5,000 US per finger. So we did, so I got that email, thought it was an interesting project. So we started collaborating from our garages. We would send photos and videos like this one to each other as we would get between each stage. we were using a lot of things like a vector set because we needed components where we knew we were dealing with the same dimensions. Because we thought it was hard with such a custom project, like to get good measurements. At one point, he took a casting of his hand, and he made a casting for me and shipped that to me so that I could have a copy of his hand in my workshop. So those are the sorts of strategies that we employed. Eventually, we got to this point that you see here, where we had just a single finger so that he could operate the trigger on his drill, that sort of thing. And he was using it to pick up toothpicks, so it had a pretty fine amount of dexterity. That was then seen by, because we were sharing photos online as we were going, updating with the progress of the project. That was seen by a lady whose son was born without any fingers on one of his hands, and she said, she basically sent us an email saying, hey, my little guy can do almost all things, but it might be neat to see if we experiment with a device that had 5 fingers, and I see that you built one. So she kind of posed a challenge to us, could we now take what you've done and expand upon it? So, again, just using the tools that he and I were familiar with at that time, which was shop prep, drill press, milling machine, more standard manufacturing tools. We came up with this initial design. We didn't have a thumb yet, so it's pretty limited in its function. But Liam, being a very determined person, and he's still one of the people that's the best at using these, because he really likes using them and puts a lot of time into practicing it. And he showed us that he could pick up the ball and various other things. So we thought, okay, this has utility, but there was a problem, which was that he was going to outgrow it extremely quickly. As fast as kids outgrow a pair of shoes, he was going to outgrow this. And the amount of time that it took Richard and I to build this first one was a lot for 2 people. So at that point, somebody at my day job at Premier Graphics at the time, here in Bellingham, suggested that I look into 3D printing because she knew somebody that was involved in that. And so, when I read up on it, as probably a lot of people in here that are familiar with technology will attest to, it's a great way that once you have a design, you can scale it to all sorts of different sizes. So this could be a way to keep up with him as he grew. So we talked MakerBot into sending us a couple of their printers for free, which they were very generous and willing to do. And then I used open source software. I used OpenSCAD as my first design program. And tutorials online on how to use that software to educate, learn how to make a basic design. And so we came up with this first printable hand, which Liam then immediately started to experiment with. Because he was our test pilot, and he would basically do it, and then he and his parents would tell us, okay, I was able to do this, and this with it. But being just 2 people, we really knew that there was only so much that we could do to carry this design forward as just 2 individuals. So our thought was to kick this out onto the internet. So we put it on Thingiverse, put it up there with a public domain license, and basically asked, if there were others that might be willing to improve upon this design. That began happening in just an organic sort of state. It was really fun to dig into this because I didn't know that there was such a thing as a maker movement. Before when I was just creating my art, I didn't know that there were all these other people out there that were tinkering with things and willing to jump on board and help with something. So, as soon as it was out on Thingiverse, people started making modified versions, creating just different components. But then eventually along came this fellow who's a college professor in New York with a background in open source software, and he had the idea of, hey, why don't we create a map where people with printers that want to print devices can link up to people that are seeking a device, and then somebody can print components and ship it somewhere else. So, so people then started popping on, putting themselves on the map. Then as of May, this has grown pretty rapidly, so there's a lot of interest around the world. So this is where we're at as of May. You can see it's filling up. But something else that was really compelling that started to happen was that we had device users and their family members joining as well, and starting to drive the process of innovation. So the R&D started to happen online, and basically, some people were doing it in makerspaces, some people in their garage. Sometimes it was a university or high school or middle school environment. But then, I like to picture Peter and Peregrine here because Peter is the father on the left. Peregrine was born without fingers on his left hand. And they together started experimenting with this design and making their own version of it. Because Peregrine was really our first adult user of one of the devices. So he put under a lot more stress. The first thing he did with it was take it out and start attacking blackberry bushes with a machete. And so he had, yeah, his dad was actually really happy about that. So he broke it. And so they started beating up the components and everything, and then sharing their additions and modifications to this design back to the community, which really helped to drive it forward. Because of Peregrine's specific knowledge of what he wanted to use it for, he was able to drive that process in a unique way. And then Peter, who was the primary designer of their team, then not only shared the files, but he came here to Washington, taught me how to build it, he taught some other people how to build their version, and really shared that knowledge person to person. And this started to become not just an electronic form of communication and collaboration and R&D, but then it started to also bleed over into the person-to-person environment. So then, this is then, he and his mom Heather, they lived in Washington State over in eastern Washington. So he and his mom learned how to build a derivative version of Peter and Peregrine's device. And then they in turn went and taught other families. And then those families started contributing ideas and suggestions for design changes to the community. And that process continued. Peter, along with myself, Jen, my wife Jen was here, and some other members of e-NABLE, then started going to visit people in more formalized environments. This is at Johns Hopkins in Baltimore. The man in the scrubs is Dr. Albert G, who's a trauma surgeon who specializes in prosthetic limbs for upper extremity. He does robotic prosthetics. He took an interest in these hands. I love Jen captured this expression on his face. What was it that he said? He said, "Shut the front door" when he held one of these, because he was blown away to see that something had been brought in from outside of the medical community that although it's a limited function device, it doesn't do anything near what these devices do. It represented an option between nothing and things that are sometimes inaccessible. So much so that he was willing to host a conference on this, bring in medical professionals. So now that we're starting to see something that started with, within garages and kind of homespun areas, finding its way to interest within the mainstream medical community. And then, at this event, though, that person-to-person is still happening. And they turned part of the Johns Hopkins Conference Center into a making space for a day, so that Luke, he's another device user that knows how to build hands. So he was running around and teaching people. Peter was there, Luke and his dad Greg. So we started, and there's John Long, another one of our community members, teaching other families who could then go on to teach other interested parties that if they knew them in their areas. This also started finding its way into educational spaces, and both traditional and non-traditional. I'd say that scouting is an educational space that where people learn a lot of this outside of the school environment. But Maria, who's a scout leader, kind of in the center of the picture there, she got on board and decided to have her scouts over in Maryland get involved with creating these and learning how to engage in making and using this as a service project, because scouts are all about that. And so the community shipped them a bunch of printed hands, and then they learned how to assemble. So this is kind of where things have gone. What we've seen through this is by making use of low-cost global communication, social media, and this movement of makers and maker spaces and people tinkering, by distributing this task over a great many people, it's made it possible to accomplish, to take this on and try and work towards solutions. So over 2 years, this is some of the things that have been developed on a budget of $0 for R&D, because it's all been done through volunteer effort, including moving towards a web app, and then eventually we hope will be a mobile app that you can type measurements into, and then we'll give you the customized parts. It's already working to a certain extent with some bugs occasionally, which Jen gets emails about because she's our communications manager. But so you know, people that are into the coding and the software world are finding a piece of it that they can assist with as well. And then, you know, in more of the university laboratory setting, there's experiments with EMG and robotics going on to find ways to make lower cost versions of the robotic limbs as well. So, you know, and I put that slide down for you, so forgive me. And this map here represents all the different countries in which each red dot is a country where at least one hand has been produced, in many cases several or sometimes hundreds, depending on the country. Of course, it's disproportionately being done in places like Europe and the United States and Canada, but it's starting to appear in other parts of the world as well. And I'll just kind of end here on this slide showing progression. And just mention a few more things. One of the things too that I always like to point out is that so what we end up with, you know, through this process is, let's say when we're about here, the first printed hand. The first printed hand was about $150 in materials and took about 8 hours of labor. Now, by the time that we're getting to, you know, these stages here, what I have in my hand here can be made for about $50 in materials and 2 or 3 hours of labor after it comes off the printer. But it has to be put into a perspective where you manage expectations, because this is a $50 plastic device. It is not as durable as a device that you would get through a prosthetics clinic. The device through a prosthetics clinic would probably be between $2,000 and $5,000, which insurance may or may not cover a portion of, depending on the case. So, you know, this being low cost is easier to replace and maintain and repair. But it's another option. The other thing too is I always like to go back to Peregrine because he has really great perspectives on all of this. Peregrine was the first person to tell me when I met him about his perspective on the hand that, you know, Peregrine, he doesn't think of it as a hand as a tool. It's a screwdriver. It's a hammer. It's something that he puts on for very specific tasks, and then other times, because he's used to not having it there, it just gets in the way. So he actually has a carabiner that he hooks his hand off his belt, and he goes around through his day, and when he wants it for something, he just takes it off of his belt and puts it on him. But there are other things. Like, my favorite example of this, I've got really big hands, right? So Peregrine asked me, hey, Ivan, how do you wash a cup? And yeah, and I thought about it, and I was like, you know what? Washing a cup's really hard for me. I have to grab a tool and use the tool to get inside of the cup. And Peregrine's like, yeah, I just wrap a rag around my paw and I shove it in the cup and I wash it. So, you know, his point was there are going to be things that he's actually better at as a result of his difference. So, you know, I thought that was a very refreshing perspective. And through all of this, though, really what makes it possible is access to technology. There's a phrase that floats out there a lot in the world of making, which is democratization of manufacturing. I really passionately believe in that because, you know, I've been able to, with other people, experience that firsthand. You know, by spaces like this one and others that are similar, provide you with access to tools that are really hard to source yourself. You know, it's one of those things that I wish that I had a space like this when I was first getting started, because, like, we would have gotten the earlier stages would have gone faster. So, and this doesn't just have utility in the social entrepreneurship space. It definitely has utility in commercial ventures, entrepreneurship. It's something that it's empowering. So I'm very excited to see this sort of things here in our community. It's unique. There aren't a lot of makerspaces in Washington State yet, and certainly not to this degree. So I'm really excited to be able to have an opportunity to speak here today, and I'd love to answer questions at this point.
I just wanted to kind of share our experience with e-NABLE. My name is Scott, and these are my two sons. There's two of my sons. Cottage and horses. Kai and Shen both have upward limb differences. And so it's been interesting in prosthetics, but much like Ivan was talking about Peregrine's experience, he's moving along for the most part, just fine. I forget day-to-day watching them do ordinary tasks. It's not an upper limb differences that go back and how there are certain things, for example, this year I was in fifth grade. Bellingham School District had a really great program that they were encouraging all fifth graders to participate in after-school violin. And they were very encouraging of all, they were shooting for 100% participation, providing violins, providing after-school transportation, etc. But Kai has about 1.7 hands. And so there was not really a way for him to, his left hand doesn't have a thumb and only 2 of the fingers will function. His hand is fixed at an angle, so forearm is short. So to do this, what you do at the upper end of a violin, you need to do that reverse. So we had a violin maker here in town reverse the violin chords. So we're still curious about how to hold the bow. So I knew there was somebody here in Bellingham who did play ball and couldn't remember his name. But I'd seen the articles on how to compose, all about this whole collaboration of the guy in South Africa. And we were a guy in South Africa that had Bellingham. So I Googled it up and I immediately got e-NABLE. It came up on my search results. And I sent out an email and Jen replied to me within an hour. And some other guys in Milwaukee emailed in on the list that they had a violin adaptive device already designed. And Paul Clements, the high school teacher at Bellingham High, who runs the design and manufacturing lab there, is emailing back that he has students interested in using this device. And it was interesting to kind of see the process that they went through. So both the boys met with him, and Shane does no right hand at all whatsoever. It's very interesting to play violin also. And so while he can use the violin on the right side of his body, he definitely needs something to hold that violin. And so this is a way where we have access to these tools. And so one of the reasons why we came here tonight is because I'm interested in the boys conversing with this technology, so they can be a program of designing tools for themselves as they go forward. Because it very much is everything where I can't imagine either one of them using one of these raptor hands like something you can get up and go out and go through your day with. I know it would get in the way. But for certain things like, bike riding and other things that I can see where something like that, or get more specific tools, like the bow horn. And that's where I'm interested in this technology, is designing those task-specific tools that enable them to do things we take for granted. And again, daily tasks, we need to put the real specific things like playing violin or something like that. It suddenly makes a huge impact.
The advantage of using things like 3D printing is that how customization is accessible.
Right.
I saw a little feature, it's probably on PBS not very long ago, about a young fellow, he was under 20, who was designing a robotic prosthetic hand. And I don't have all my memories, a little vague on this, but the innovation there was on neural control for robotics. He had like some little thing to put around your head, and he was able to have little servos on it. So actually brain waves were able to tell the hand to squeeze and move around. Is this network involved in any of that kind of application?
So not as of yet. That young man is Easton LaChapelle. I think Yeah, what he's working with is a method of control that really relies on focus. So it doesn't, it's not able to differentiate between a lot of motions very accurately, but it can basically tell the hand to go into active mode or to stay passive. But there's a lot of potential for that in the future. So the e-NABLE network hasn't branched out there yet, but there are several offshoots of the network that are looking into EMG technology, which is sensing the nerve impulses of muscles.